It's great to be here. Thank you, everyone, for coming. And I'll just dive in. I think the problem that made me want to give this talk today was a recurring one. So an early instance was in 2022 when we had very close to each other headlines about deep learning hitting a wall, and then ChatGPT launching, whole new revolution. Last year, we had coverage from the Wall Street Journal about real challenges with some really good reporting inside OpenAI with scaling up their pre-trained models and how difficult that was and how they were unhappy with the results. And then on the literal same day, we had the release of O3, the next generation of their reasoning model, and Francois Chollet, who's sort of famously skeptical, saying that it was a significant breakthrough on his ARC AGI benchmark. So these very contradictory takes, both of which had some truth to them. And then last month, two big kind of papers or outputs that I'm guessing many folks here have seen. One on making the case that AI is just a normal technology, basically, and it's going to follow the same path we've seen in many previous technologies. The other describing how we might have AGI by 2027, superintelligence by 2030, and an absolutely radically transformed world. Again, I think very, very different perspectives, both of which have some truth to them. So basically, this talk is for anyone. You can raise your hand if you've ever been personally victimized by the onslaught of AI news and how contradictory it is. So yeah, this talk is for you. If you didn't raise your hand, you can leave. I won't take offense. It's fine. So a friend saw the title of the talk and said, wait, how did you get them to give you a 9-hour slot to cover all the unresolved debates? So we're just going to talk about 3 debates. I'm going to focus on technical debates, meaning how will AI evolve as a technology? So not what are we going to do about it or how will it affect society, but how is the technology going to evolve? And debates that are the most relevant in my view, or are, according to me, a helpful way of breaking down some of the disagreements. So in other words, we're not going to talk about timelines to AGI, and we're not going to talk about PDOOM, because I think both of those are not as productive. OK, so here are the 3 that I want to talk about. How far can the current paradigm go? How much can AI improve AI? And will future AIs still basically be tools, or will they be something else? People often talk about kind of is scale all you need, or can you scale language models all the way to AGI? I don't think this is that helpful of a question, or I think it's a little bit misguided. I would rather ask, are we on a good branch of the tech tree? So if you imagine that we're kind of exploring this tree of potential technologies to develop, and we've explored some of the paths further than others, and the current one that we're on, we call it different things, but I'm going to call it the generative pre-trained transformers branch of the tree, GPT. And the reason I find this more useful is it's not really the case that we've just sort of taken GPT-1 from, what was it, 2018 or something, and just scaled that. Instead, we've been kind of adding on different architectural changes, different ways of gathering and processing data. We're now doing reasoning. We're now doing agents. But it's all kind of continuing along the same branch of the tree or similar branches. And so one way, this debate, how far can the current paradigm go? If it can go a long way, that would mean we can keep going in this sort of branch of the tree that we're on, and it keeps bearing fruit, so to speak, to like semi-mixed metaphors. Versus maybe we need to kind of backtrack and go on a somewhat different branch of the tech tree, or maybe we need to go a long way back and maybe not even do deep learning or do something that's very, very different to language models. So that's how I'm thinking about this debate. Different arguments for whether we can go far or not. One really important one, I think, is just recognizing that all of the progress we've seen over the past kind of 10, 15 years has come from not big paradigm shifts, not big breakthroughs, but instead these different small to medium size improvements, I would say. So this is coming back, if we're looking 2015, 2016, starting to get reinforcement learning to work on games, figuring out how to combine it with tree search and solving, beating human performance on Go. The transformer, which was a big deal, came out in 2017, the basis of all of our current language models. That was sort of a, big improvement, but not a paradigm-shifting improvement on LSTMs, long short-term networks. Just a long, long history of these sort of short to medium, small to medium improvements. So we might keep seeing a lot of progress from that. The second one, I think people often say, again, with scaling, they say, do we just need to scale what we have? But if you talk to the people inside AI companies who are doing this, the people doing the research, they don't think about just like dialing up the scale knob. Instead, they think of a big part of their job as finding things that you can scale, finding things where if you dial up the scale knob, you get good returns. And if you talk to people inside those research teams right now, they think they have quite a few new things that they can keep scaling, that we're at the beginning of. Things like reasoning training, multimodality as a new source of data, figuring out ways to train agentic capabilities at scale. And so it's, if we need things that you can turn the scale dial up and get good returns, and it looks like we might have a few right now that we're still on the early side of. And then another thing to just be keeping an eye on is, again, for the companies and the research teams doing this, data is very valuable. And one really great way to get data is to have real-world adoption that you can then use to train your future systems. So as language models and kind of the technologies on the GPT branch of the tree are starting to be useful and starting to be adopted, that means that we're going to get more of that sort of flywheel, more of that reinforcement. There are also reasons to think that the current paradigm won't get us that far, or won't keep going that much further. So there are some really big issues that have repeatedly caused problems for GPTs and that are still unsolved today. So these include hallucinations, also known as confabulations, just making information up. Reliability, so there's this capability-reliability gap where the capability, you can show that an AI system can do something, it can do something very impressive, but if it doesn't actually do that 90, 95, 99% of the time, it may not be that useful depending on the application. And we really haven't seen anything nearing really high reliability on some of the most sophisticated tasks. Overconfidence, another big problem for these models. They ask you ask a question, they have no idea when they should say, I don't know, or I know. They're not very good at recognizing if they've made a mistake and backtracking. Maybe they're getting better. Maybe these won't be intractable forever, but they have been, I think, harder than some people would expect. There's also fundamental limitations to the way that we build GPTs right now. A big one is they can learn things that are in their training data when they're trained in this one big chunky way, and then you can put things in their context window for any individual use case. We don't really have good ways right now of doing something in between. So having an AI system that you're using for some task at work, and it does it a bunch of times, and it gets better over time, and it remembers, 6 months ago you had some conversation and it didn't seem relevant then, but it's relevant now. It can go back and look at its notes or whatever. We really don't have this sort of setup, and people are trying things where you can build a knowledge base and get the AI to change its knowledge base and things like that, but it really isn't sort of an inherent part of the way that we build AI right now, and it's not really working just yet. Likewise, lack of a physical body. Most of the AI systems we're using right now are not embedded in physical systems. There's definitely some interesting progress happening on robotics, so again, maybe this will change. But for now, I think it is a pretty significant limitation. And then it does seem actually pretty clear that the improvements that we're getting from just scaling pre-training, so that initial phase of learning to imitate text or other kinds of data, it does seem like the value of continuing to scale that is slowing a little bit. And it's also at a point where continuing to scale it means spending hundreds and hundreds of millions of dollars. And so if the value is not worth hundreds and hundreds of millions of dollars, it's going to maybe be difficult to keep moving up that curve. Everything on both sides of this ledger, I think, is pretty unclear, uncertain. How good are those arguments on the left-hand side? How good are those arguments on the right-hand side? I don't want to claim any of it is 100% solid, but I think it's all worth taking at least somewhat seriously. And I think this chart, who's seen this chart? Hands up if you know this chart. Yeah, so I think how people interpret this chart is a pretty good encapsulation of the debate. So this is for anyone who hasn't seen it. It's a chart from an organization called Meter, which is a really excellent third-party kind of AI, science of AI, evaluating AI independent tester. And they created a data set of tasks that take a different amount of time for humans to do. And then they measured how well can different AI systems perform those tasks, and how long are the tasks that they can do well. So with the idea being that if you can perform a task that takes a human an hour, that's going to be a harder task than something that takes a human 20 seconds. And you see this curve over time, or this improvement, where the length of tasks they can do is doubling every 7 months. And actually recently, I think more recent data has maybe shown it curving up. So some people look at this task, they say, this shows AI can do longer and longer tasks. If you extrapolate the curve, you get something like AI being able to do tasks that take a month by 2030, something like that. So that would be very, very complicated, or really, much more complicated than AI can do right now. Other people look at this chart and they say, well, but look, it's a 50% success rate. So these are what are the kind of tasks where, what are we looking at? GPT-4 right there in the middle can do something like, a 5-minute task, but it only gets it right 50% of the time. That's not actually practically useful. And if you make the same chart looking at 90% success rate or 99% success rate, it looks much less impressive. Also, these tasks are, they're kind of divorced from context. They have to be, in order to run the test, they have to be these kind of bite-sized, isolated little chunks. And they're only software and reasoning problems. They're not a broader set. So a different perspective on this chart would be to say it doesn't really tell us much at all, and it's only this one specific type of progress on this one specific type of problem. And again, I think there's something true to both perspectives, and only time will tell what the answer is. The second big debate that I think is pretty core to a lot of other disagreements is how much AI is going to be able to improve AI. So this original idea, I think, was maybe first pithily expressed by this guy, I.J. Good, who was an early computer scientist who worked with Turing. And he wrote this interesting paper about ultra-intelligent machines. I'm waiting for that term to make a comeback. I feel like it's a great, very fun term. And he says, if we had an ultra-intelligent machine that exceeded human performance on all tasks, then it would therefore be better at building more ultra-intelligent machines. And so, quote, there would then unquestionably be an intelligence explosion, and the intelligence of man would be left far behind. So he doesn't say anything about the intelligence of woman, so we're good. Just kidding. But so this is the basic idea. If you can use AI to improve AI, and the AI gets better than the humans at improving the AI, then you get this kind of hockey stick curve feedback loop situation. And this is already actually starting to happen. So what's that, like 60 years ago that he was talking about that? But now, just the last few years, we're starting to see really meaningful signs of this. So AlphaEvolve is a result from Google, where they use their cutting-edge language models as part of a system to improve algorithms, evolutionary discovery of better and better algorithms. And it actually, that system managed to accelerate the training of the LLMs that were in the system. So it was kind of improving itself. I think they said they sped up the training of a Gemini model by 1%, which when you're talking, again, about hundreds of millions of dollars, 1% starts to be real money. We also have, this is a really interesting, this is just a former colleague of mine, Ajaya Kotra, who does really great work on this. She's doing some informal surveying of machine learning researchers and engineers, and she said based on number of conversations that they were already finding that AI was helping them in their research and engineering work. Especially junior folks were seeing somewhere between a 10 and 150% increase in productivity due to using AI tools. Senior researchers, somewhat smaller, but still meaningful, 2 to 30% increase. And then just as I was preparing for this talk, I found this pretty interesting statistic, which was, so this is Claude Code is an Anthropic tool that helps developers code using Claude, hence the name. This is the lead engineer on that project, and he said on a podcast that the code underpinning Claude Code itself, the percentage of that was written by Claude was 80%, or around 80%. So a very large proportion of this coding tool was written by the AI that is powering the coding tool. But still, we don't actually know how much further this will go. So there's a question, if the AI can do everything that AI researchers and engineers can do, then you naturally get this feedback loop where everything is just limited by, for example, the available computing power. But if you hit other bottlenecks, if there's other things that will slow things down, then you might not get that kind of hockey stick recursive growth. So some potential bottlenecks. Right now, the big one is that the coding tools make error, or the research tools, any AI being used for AI research, makes errors, and so you need to check it. This is a big reason why the productivity that those researchers were reporting on the previous slide is not that high yet. They still need to be looking at everything the AI is doing, running tests, checking the tests work, et cetera, et cetera. In the future, maybe there'll be less errors, but maybe if the AI is just kind of writing code or executing sort of pretty simple instructions, then it doesn't necessarily have the kind of research taste or judgment that you need in order to really automate that full research and engineering cycle. And then even if you could automate that, maybe there's real-world experiments that you need to run, or maybe real-world deployment. Maybe you need to actually put it into a real organization or a real, real company in order to see what works, what doesn't, and get that feedback. And so those could all be bottlenecks. But then again, how sure are we that all of these bottlenecks can't be automated? I'm not 100% sure. I think it's a little bit of a wait and see situation. And I think time will tell which of these are really bottlenecks and which of these are actually can be automated. Okay. Third disagreement is about future AI systems and whether it will make sense to think of them as tools. So this paper, if you haven't read it, I really do recommend it. It's by Arvind Narayanan and Sayash Kapoor at Princeton, who write the AI Snake Oil blog. It's very rich. It has a lot of really nice articulations of positions that I think many people intuitively hold about AI but haven't necessarily expressed. They say, quote, "We view AI as a tool that we can and should remain in control of." Another famous sort of skeptic of AI risk, Yann LeCun, has expressed a similar perspective. Future AI systems will be safe and will remain under our control because we set their objectives and guardrails, and they can't deviate from them. And I think it's really important for anyone who doesn't think of AI this way or doesn't think of future more advanced AI systems this way to just spend some time sitting with the fact that this really is, I think, a very reasonable starting point. It is the way I think pretty much all AI systems work today. It's the way that most technologies work. And it also is something that we have experience dealing with as well. And so if it does seem like AI is going to continue being a tool where we determine how it's used, you kind of open up your ChatGPT app, you type a question, it answers you, you close the app, we're done, then it means that things are going to be quite a lot simpler in many ways than if that's not the case. So if this is true, then we don't really need to spend too much time worrying about the goals of the AI system, what values it has. It's still somewhat relevant. You still care, if you ask a question about some political question, you care, what sort of responses you're getting. But that's less, a question of sort of the nature of the AI itself and more just, a little bit more about sort of content. Likewise, or another implication is that if AI systems continue to be tools, then people are going to be really, really central. So it's not about what does the AI want, what is the AI going to do, it's about who is using the AI, what are they going to do with it. Maybe we still worry about kind of malfunctions or failures, but it's still, again, much more comparable to past technologies. But I think there are some things about AI that are quite different from past technologies. So one is this idea that you'll hear from researchers quite a lot, that AI systems are grown, not built. And what they mean by this is, in contrast to, say, a smartphone, where the smartphone is built up of these little components, we put them together, and we really understand at a very detailed level how each of those components work and how they fit together to make a smartphone that does all the complicated things a smartphone does. When it comes to AI, machine learning systems, deep learning systems, large language models, that's really not how they're developed at all. Instead, we have these algorithms that we run over data using mathematical optimization processes that tweak all these billions or trillions of numbers and end up with something that seems to work. And we can test it and see what does it do, how does it seem to behave, but we really don't have that component by component understanding that we're used to having with technologies. And so that makes it something a little bit more akin to an organic system, a plant, an animal, something that is grown, as opposed to, or even just a bacteria, as opposed to something that we kind of construct piece by piece ourselves. There's also something really unusual about AI systems that is just starting to pop up over the last year or two, which is this idea of situational awareness. So you don't have to worry about kind of consciousness or any big philosophical concept. That's not this. Situational awareness is just, does the AI seem to be able to account for the situation that it itself is in? And so something we're starting to see is AI systems that notice and remark on the fact that a testing situation that they're put in, some strange hypothetical, seems like it's a test. And so then if they can tell that they're in a testing situation and they behave differently because they think they're in a testing situation, kind of obviates the point of the test. And we're very not used to technologies behaving this way. This is really not what your smartphone is going to do if you're running some test to make sure that it survives in water or something like that. It's not going to be like, oh, I'm being tested, so I'll behave differently in the water than I would otherwise. So this is really not usual when we think about technologies that are tools. And a final one, which is sort of something for the future, is that there are, I think, very strong financial commercial incentives to build AI systems that are very autonomous and that are very, very general. So systems that you can give kind of big picture, high level, long horizon tasks, complicated tasks, and let them go out and do them autonomously without much review, without too many constraints. It may turn out that it's not feasible to build AI systems that work that way. It may turn out that we're able to decisively act and decide that we don't want to build AI systems that work that way. But I think the default path we should expect is that there are really strong incentives to do that. And so if it's technically possible and we don't have some kind of significant intervention, those are the kind of systems that we're going to get. And if that's right, then I think if you have very autonomous, very general systems that are operating in complicated contexts, then it's not really going to make sense to think of them as tools. One quote I found helpful here was from Jack Clark, who's a co-founder of Anthropic. He leads policy there. And he wrote, this is an excerpt from a longer piece that I thought was very thoughtful on his Substack, Import AI. He wrote, we should expect volition for independence to be a direct outcome of developing AI systems that are asked to do a broad range of hard cognitive tasks. He says, we're not making dumb tools or training synthetic minds. They have economic value, which grows in proportion to their intelligence. So what I like about this quote is, again, it's not saying we're going to make people, they're going to be conscious, they're going to have feelings. Maybe some of those things are true, maybe they're not, but that's not what we're talking about here. What Jack is talking about is just the fact that we're training systems to do difficult, economically valuable things in very general purpose, open-ended ways, means that we could get these sort of strange-seeming behaviors that really don't characterize a tool. We could see those in AI systems, and again, we're already starting to see initial glimmers of that. So I think these kind of reasons are reasons to expect that if the technology keeps progressing, it may really stop looking like a tool and look like something a little bit different. Maybe more like, people will sometimes say, a second species. And then a final thought will just be, for this debate, if maybe one side is it's going to just clearly be a tool, a different side is it's going to be something like a second species, maybe an intermediate position that perhaps we're starting to see already, but maybe not, would be to think of AI as a optimization process, a maybe self-sustaining optimization process of the kind that maybe a market is or a bureaucracy is, where it's not a tool, it's not something that you just pick up and use and then put down and it stops doing anything. It's also not necessarily a being or a mind, but it is still very powerful, and it does make sense perhaps to think about what it is optimizing for, what kind of goals it has, what it might be likely to do in the future, as opposed to just being a tool. So I think this is a maybe a little bit less sci-fi sounding way of thinking about this sort of spectrum of possibilities as well. That is where I'm going to leave it today. It looks like we have time for a couple of questions, but I hope that thinking about these three different ways of breaking down some of the kind of intractable and sometimes kind of unproductive debates in the space, to instead be breaking them down into these three questions, I hope is helpful as you go about thinking about this space. Thank you.